This video is on section 8.2 notes, testing a claim about a proportion. So in the previous video in section 8.1, we looked at the basic concepts of hypothesis testing and the formal hypothesis test procedure, which included 8 steps. And we have some of those steps listed here. And it probably felt overwhelming and confusing because it was the first time you saw the steps. And then we were also doing it for all the different population parameters. We looked at a proportion in one example. I think we looked at a mean in another example. And we were just trying to get kind of a big picture perspective of what the whole process looks like. So now what we're going to do in each section is look at one of those population parameters at a time. So where it felt overwhelming before because we kind of had to pick and choose what type of problem we were doing, here we're backtracking and we're just going to focus on population proportions. So we won't have to pick and choose which one we're going to work with. We'll know exactly what we're working with. It's going to be P, population proportions, and we're going to see how this hypothesis test procedure works specifically when you're doing a proportion. And then in the next section, we'll study one of the other population parameters, and then in the section after that, we'll talk about the one that's left over. So hopefully the next time you have to look at the big picture perspective again, you'll have a better understanding of kind of like the nitty-gritty details for each individual population parameter. All right, so first I'm going to go ahead and read the example. It says, in a presidential election, 308 out of 611 voters surveyed as they left the polls said that they voted for the candidate who won. So the results hadn't been announced yet. They had literally just voted. They walked out and they said, yep, I voted for the winner. Use a 0.10 significance level to test the claim that among all voters, the percentage who believes they voted for the winning candidate is equal to 43%, which is the actual percentage of votes for the winning candidate. So did people who voted for the winner know that they voted for the winner? Were they right? What does the result suggest about voter perceptions? Okay, so first step and second step are similar. First was to identify the claim to be tested and express it in symbolic form. And then second was to give the symbolic form that must be true when the original claim is false. So state what we're testing and then state the opposite of what we're testing. So what we're testing is if the percentage of people who believes they voted for the winning candidate is equal to 43%. So is the proportion equal to 0.43, because we're looking at a proportion, not a percentage. So is the proportion of the population that voted for the winning candidate equal to 0.43? And then the opposite of that would be not equal to 0.43. And then from there, we're going to identify the null and alternative hypotheses. And so the null hypothesis is always the one that includes equality. So I was thinking of the alternative there. That's why I wrote the A. So P equals 0.43. That includes equality. And then the alternative hypothesis is just the other one. Okay. Next, we're going to identify the significance level, and this was written in the problem. So they said in the problem to use a 0.10 significance level. So alpha is 0.10. Okay. Now the next step in the last video, this was one of the more difficult things for us to do. We had to identify the test statistic that we would be finding. And here it's not going to be difficult at all because we're going to do proportions for the entire section. So we're looking at population proportions. And so we're going to convert the population proportion that we have into a z-score. And so our test statistic is going to be a z-value. Based on the symbol of our alternative hypothesis, we have a do not equal symbol, so we're going to have a two-tailed test. I went back to section 7.3 notes and I pulled a table that we had used there to figure out our critical values, and I adjusted the table a little bit to have room for two-tailed critical values, which we had already worked with, and then also to create one-tail critical values, which we had not worked with. So I found these values for you. So here, for two-tailed critical values, if you were to have found them on your own, you would have had to take the alpha value and divide it by 2 and then look up the z-scores on the table based on that probability. Here, for a one-tailed critical value, you would have used the actual alpha value. So our alpha value is 0.10, and we're talking about a two-tailed test. And so our two critical values are negative 1.645 and 1.645, and I will draw those in a little bit. Okay, on to step 6, we're going to find the value of the test statistic. So I'm going to write down each of the values that we will need to compute that. So I have p hat, which is the sample statistic, 308 out of 611. .5041. I like to have a few decimal places there, about 4 for any number where I know it's not my final answer. I'm going to use it in another computation. The p-value was given to me in the problem, 0.43. The q value is the complement of the p-value, so 1 minus p, that's 0.57. And then the n value is the size of the sample, which was 611. So the z-score is going to be p hat, 0.5041, minus p, divided by the square root of p times q, over n. And I was just using this formula right up here. Okay, so I'm going to go ahead and type that in. I can type that fraction, this fraction right here that I can see. If I do the green button, alpha y equals, I'll get a fraction. 0.5041 minus 0.43. And then on the bottom, I need a square root. 0.43 times 0.57 divided by 611. I get that this is approximately 3.69 followed by a 9 would round it up to 70. And I'm rounding this to 2 decimal places because this is a z-score. And when I look at my standard normal distribution table, my z-scores always had 2 decimal places. So that's why I'm looking at that. Okay, so so far, I've found my test statistic. I'm looking at my critical values. I have not looked at the p-value yet. And if you remember from the notes before this, you can make your conclusion based on the test statistic and the critical value, or you can use the p-value. And when I make these videos, I'm always going to use both. But you really can do one or the other. You'll have enough information either way. So this was a two-tailed test, and so we're going to have a number over here and a number over here. So this is our first critical value, negative 1.645, and then positive 1.645. So if our z-score is to the left of negative 1.645 or to the right of positive 1.645, then it's going to be in the rejection region, and then we will reject the null hypothesis. So 3.70 is somewhere over here. And so because of where it is in the region, we know that we're going to end up rejecting the null hypothesis. And if our method of doing this hypothesis test is to use the critical value, which is what we've just done, then we have enough information to reject the null hypothesis. But I'm going to go ahead and I'm going to use p-values as well because some students don't prefer this method. And so if you are a person who prefers the p-value, then the p-value is found by taking the probability that z is greater than 3.70. I know that I'm saying the probability that z is greater than that value as opposed to saying that z is less than that value because I'm comparing it to the larger of the critical values. I'm not comparing it to the smaller one. If it had been negative 3.7, then I would have compared it to the smaller one and I would have used a less than sign. All right, so the probability that z is greater than 3.70 is what I'm looking for. And I'm going to go ahead and I'm going to grab my standard normal distribution table. And I'm going to look and see what a z-score of 3.70 is. It is 0.9999. Now, this probability, the probability that you get this z-score, is always the area from the left. It's always less than that z-score. The probability that you get something less than that z-score is 0.9999. So if I want the probability that I'm going to have a number greater than that z-score, then I need to find the complement of this. So I'm going to say the probability that my z-score is greater than 3.70 is 1 minus 0.9999. If it had said the probability that z was less than 3.70, I would have just taken the 0.9999 and used that as my answer. All right, so the probability that this is going to happen, the p-value is 1 minus 0.9999, which is I'm going to show you 0.0001. So 1 minus 0.9999 is 0.0001. Your calculator is a little bit uncomfortable with it. That's why it gave it to me in scientific notation. This is 1 times 10 to the negative 4th power. So this is almost my p-value. Because this is a two-tailed test, I have to take this answer and multiply it by 2. So 0.0001, multiply it by 2, because it's a two-tailed test, and I get 0.0002. That's my p-value. Okay, so at this point, we know that the p-value, 0.0002, is less than 0.10. And this is also, if you remember the next step, this is also a reason to reject the null hypothesis, okay? I don't have to write anything yet. I'm going to turn to the next page in my notes, and I'm going to look at step 7. Step 7 says to make the decision to either reject the null hypothesis or fail to reject. And we remember if the p is low, the null must go. So since the p-value is lower than the significance level, the null hypothesis has to be rejected. So we're going to say we reject the null hypothesis. Okay? Next, we have to write our sentence using simple and non-technical terms to kind of interpret what we just said. So first, we need to determine if the original problem, if that condition used equality, and it said equal to 43%. So it did claim equality. And so we're looking at the original claim contains equality, yes. And then did we fail to reject the null hypothesis, or did we reject the null hypothesis? We rejected it. And so when we write our sentence, we're going to phrase it this way. There is sufficient evidence to warrant rejection of the claim that the percentage of voters who believe they voted for the winning candidate and were right is 43%. So we just take the claim from the problem and we put this sentence starter in front of that claim, and then we're done. Okay, let's take what we've learned and let's do it again. So this next problem says, in a survey of 1,500 households, it was found that 47% of them had a smart TV. So this is our sample. Use a 0.01 significance level to test the claim that fewer than half of all households have a smart TV. So the claim is that fewer than half, fewer than 50%, have a smart TV. So the proportion is fewer than half, fewer than 50%. The opposite of that is that P is greater than or equal to 50%. The null hypothesis is always going to be exactly 50%. Or exactly equal to. So we're going to say the null hypothesis is P equals 50%. And so that's referring to this second one right here. This is the one that has equality. We don't use this symbol. We use just the plain equal sign, but it's referring to this one. And so the alternative hypothesis must be the other one. P is less than 0.50. Okay, identify the significance level. We have alpha is 0.01. Okay, now the next step is easy. We only have one test statistic to work with, and so we know for sure we're going to be looking for the z-score. In this case, we are testing the alternative hypothesis that P is less than 0.5, and since P is less than 0.5, that's a one-tail test, and so we're going to be working here. We had that our significance level was 0.01, and so we're working with the critical value 2.33. Because it's a less than symbol, we're going to be working on the left side. It's going to be a left tail, and so we're going to have negative 0.233 as our critical value. We're going to use the left side. Okay, so now we can find the value of the test statistic. So we have P hat, they just gave it to us. They said, so this is a typo. It'll be changed by the time you guys get the notes. I read 47%, but it'll say 46% on your papers. So we're going to have P hat is 0.46. The P value is 50%. The complement of P is 1 minus 0.5, which is also 50%. And then the number of the sample size is 1,500. Okay, so we have our z-score is P hat minus P divided by P times Q over the sample size. So we have 0.46 minus 0.5 divided by the square root of 0.5 times 0.5 divided by 1,500. So negative 3.9 is followed by an 8, so the 9 is going to round up to 10. So negative 3.10. I'm going to go ahead and draw in my normal distribution. I have a left tail over here with the critical number negative 2.33. Again, I know it was a left tail because my my alternative hypothesis was that P is less than 0.5. That's why I had a left tail instead of a right tail. And then over here, I have my z-score, which is going to fit right there in that rejection zone. Negative 3.10 is a number that's less than 2.33. Negative 2.33, so it's going to fit in that shaded area. So we're going to be rejecting the null hypothesis. But I'm going to go ahead and find the p-value anyway. So the probability that z is less than negative 3.10, and I'm going to be looking at my table. So I'm going to flip it to the negative side. This time it's less than, and our areas are to the left. And so this time I'm not going to have to find the complement of the number. I can just find the number and use it as is. So 3.10 is 0.0010. I don't have to multiply it by 2 this time. I can just use the number because this is a 1-tail critical value, not a 2-tail critical value. So I don't have to double it. I can just use it as is. So P is equal to 0.0010. This number, 0.0010, this is 1/10, 100th, this is 1/1000th, and our significance level was 1/100th. So 1/100th is definitely going to be larger than 1/1000th, or you could say 1/1000th is smaller than 1/100th. And so if the P is low, the null must go. So we know that either from using our critical value or from using our P value that we are going to reject the null hypothesis. We reject the null hypothesis. And again, you don't have to show both of these methods on your paper. You can find the z-score, the -3.10, and you can do either this or this. You don't have to do both. I'm doing both because I'm teaching you, but you don't have to do both to make your conclusion. You can do one or the other. Or maybe it's good to do both as a way of checking your work. That would be fine as well. Okay, so if we look back at the original problem, did it say equality? It said fewer than half of all households. So that did not say exactly half, that said fewer than half. So it does not, the original claim does not contain equality. Did we fail to reject the null hypothesis, or did we reject it? We rejected the null hypothesis, and so that means this is the sentence starter that we're going to use. So we're going to say there is sufficient evidence to support the claim. There is sufficient evidence to support the claim that fewer than half of all households have a smart TV. So since, I wrote that weird. So since we rejected the null hypothesis, that means that we are saying that there's evidence to believe the alternative hypothesis. And the alternative hypothesis was that the proportion was less than 50%. So there is sufficient evidence to support the claim that fewer than half of all households have a smart TV. Okay, let's go ahead and try one last example. And maybe at this point you're really understanding it. If that is you, then I would say pause the video, work out the whole problem on your own, and then unpause and just kind of fast forward through and see if you got the answers right. So this example says, in one study of smokers who tried to quit with nicotine patch therapy, 39 were smoking 1 year after the treatment and 32 were not smoking 1 year after the treatment. Use a 0.05 significance level to test the claim that among smokers who try to quit with nicotine patch therapy, the majority are smoking within 1 year after treatment. So when they say majority, they're talking about more than 50%. Do these results suggest that the nicotine patch therapy is not effective? So the claim that's to be tested is that the proportion of people smoking 1 year after nicotine patch therapy is greater than 50%. And the direct opposite of that would be that the proportion is less than or equal to 50%. So the null hypothesis is always the one that has the equal sign. So that the proportion is exactly equal to 50%, And the alternative hypothesis is whichever one did not include the equal sign, so that P is greater than 50%. The significance level that was given is 0.05. Okay. We already know our test statistic. We're going to find the z-score. The significance value that they gave us was 0.05. Our null hypothesis is a greater than, so this is going to be a one-tail test. We're going to be using this as our critical value, and what's more is because we're using greater than 0.5, we're going to have the positive version, not the negative version. Okay, let's go through and find the value of the test statistic. So P hat is going to be the number of people who were smoking 1 year after the treatment, that's 39, divided by the total number of people in the sample. And the total number of people in the sample were those who were smoking plus those who were not smoking, so 39 and 32. So 71 people in that sample. So that means that P hat is 0.5493. 0.5493. Okay, P is 50%. Q is the complement of 50%, which is still just 50%. And then the sample size is 71 people. So the z-score is P hat minus P, 0.5493, minus 0.5, divided by the square root of P times Q divided by the sample size. Okay, so 0.5493 minus 0.5, square root 0.5 times 0.5 divided by 71. There's our z-score, 0.83. I'm using 2 decimal places, 0.83. Okay, I'm going to draw my standard normal distribution so I can put my critical value in. So here's the right tail rejection zone or rejection region. My critical value is 1.645, and then 0.83 is going to be somewhere in here. So I'm going to fail to reject the null hypothesis because 0.83 is less than 1.645. It's somewhere over here. Okay, to find my p-value, I'm going to find the probability that z is greater than 0.83, kind of like the probability that z is in that rejection zone, probability that z is greater than 0.83, and I'm going to grab my standard normal distribution table. I'm going to look for 0.83, and I know that because this table measures areas from the left, I'm going to have to get the complement of this probability. So I'm not going to say that my p-score is 0.7967. I'm going to have to do 1 minus that number. So 1 minus 0.7967. 1 minus 0.7967. So 0.2033. So again, 0.7967 is actually the probability that z is less than 0.83. So to make it so it's the probability that z is greater than 0.83, I needed to do 1 minus. I needed to find the complement. The p-value is 0.2033, and that is definitely greater than 0.05. And since we know if the p is low, the null must go. In this case, the p isn't low. The null must not go. So we fail to reject the null. Okay, I'm going to look back at the original phrasing of the question. So the majority are smoking 1 year after treatment. So we were looking at P is greater than 0.50. That's what we were trying to find. The original claim does not contain equality, is what we found. and we failed to reject the null hypothesis. And so this is what we are going to be reading and writing as our final sentence. There is not sufficient evidence to support the claim that among smokers trying to quit with nicotine patch therapy, the majority are smoking 1 year later.